Hey everybody, we're in our limits and derivatives unit, and this is video 10. You should have a note sheet that that has intervals of increase and decrease on it. I'm going to go ahead and do the front side of the worksheet with you, leaving the back side for you to try on your own. Alright, so talking about intervals of increase and decrease, we're talking about covering all of our x values. So these intervals are describing our x values. So basically the entire domain. Alright, so the first thing we need to do is we need to talk about what it means for the function to be increasing or decreasing. A function is increasing if the slope of the tangent line is positive, and a function is increasing, let's write that correctly, sorry, and then the function is decreasing when the slope of the tangent line is negative. So we're looking for where is the slope increase or a positive and where is the slope negative. Well, we didn't discuss what happens when the slope is 0. When the slope is 0, we're actually identifying a maximum or a minimum. So we've actually talked about that when we were together in class. Or you can reference back to video 9. So when the slope equals 0, we have a maximum or minimum. When it's positive or negative, we have an increasing function or a decreasing function. So first let's identify where it would be 0. So here our slopes would be 0. I'd be able to draw a tangent line where the slope is 0. Everywhere over here my slope is negative, and everyone over here my slope is positive, and then again over here the slope is negative. So if I'm talking about increasing and decreasing, let's write it in this way. We're going to say f of x is increasing, and I'd be looking between -2 and +1. So increasing between -2 and +1. So where is f of x? Oops. Oh gosh. Going a little crazy here. Where is f of x decreasing? Well, it's decreasing from -infinity all the way to -2. But it's also decreasing from +1 to +infinity. You're saying, well, that's not going to it's not going to positive infinity. Well, the x values are going to positive infinity, and we are describing the x values. So while my x's are going this way, yes, the function is decreasing, but it's going to -infinity. So we will write that as +1 to +infinity. Okay, so I'm going to grab another pen color. We can take a look at the second one together, just so we can distinguish my problems. So I'm going to again identify where the slope is 0, and that will help me determine where my intervals begin and end. So if I'm talking about increasing, I would say f of x for number 2 is increasing. It's increasing between -2 and +1, but it's also increasing from +3 to +infinity. Okay, so where is f of x decreasing? Well, f of x is decreasing from -infinity to -2 and from +1 to +3. Oops. So we said from -infinity to -2, and I'm using this union symbol, and it just means those two combined, from we said right here, which was +1, to here, which is +3. So I've covered the entire domain. I've covered everything from -infinity to +infinity, but I'm separating it as to where is my slope positive and where would the slope be negative. So let's take a look at this algebraically. So now I don't have a picture, so I'm going to have to first determine where my slope is equal to 0, because that separates my increasing from my decreasing. So to do that, we're going to go back to what we had done in class, or you can look at video 9, and that is to take the first derivative and set it equal to 0. So my first derivative using the power rule is 2x minus 4. I'm going to set that equal to 0, and I get x to equal 2 when I solve. So at 2, my slope is 0. So there's a minimum or a maximum at 2. So on the left or on the right, I must have something increasing or decreasing. To do this, we're going to be using something called the first derivative test. My first derivative test says, well, let's just take a look on a number line, that there are numbers that are on the left side of 2 and there's numbers on the right side of 2. And these are x values. So I want to know f prime of x, it's a first derivative, and I want to test some points. So using my first derivative, which we have up here, let's test points over here. So we're going to test, for example, 0. I like 0. It's a nice number to substitute in. And on the other side, I'm going to test 3. I'm going to test them in the first derivative. So if I substitute in f prime of 0, I get negative 4. So that means my slope is negative. Well, if the slope is negative over there, it means all of my slopes are going to be negative on the left side of 2. If my slopes are negative, I have an interval of decreasing. Go to the other side, let's test f prime of 3. I'm testing them in my first derivative because it's the first derivative test. When I test 3, I get a positive value. I get positive 2. 6, 2. Yes, I get positive 2. So all of my slopes over here are positive. So in other words, I can write that f of x is increasing from positive 2 to positive infinity, because that would be all of these values here. It's where it's increasing. But f of x is decreasing from negative infinity to positive 2. Okay, now 2 is the border between those two because that is when the slope is equal to 0. If you were to test f prime of 2, we would get 0. Let's try another one together. Okay, for this one, I've got a cubic function, so I may have more intervals than just the last one. We're going to begin by finding the first derivative. That's going to give me 12x squared plus 16x minus 16. I need to factor this because I need to see where it's equal to 0. 12x squared plus 16x minus 16 equal to 0. I'm going to factor out a common factor of 4, giving me 3x squared plus 4x minus 4, still equal to 0. Now you can use whatever way you want to factor this. Okay, I'm going to just go ahead and use kind of a guess and check way, but a logical guess and check. I know I have to have these last two multiplied to negative 4. Now if I use positive 4, I'm going to get a 12, and that's too big to make the 4 in the middle. So I'm actually going to use over here a 2 and over here a 2, making this 2x and 6x. Well, if I make that positive 2 and a negative 2, I get the positive 4 for the middle. Again, you can use the AC method or any other method that you have for factoring. Now this gives me two places in which the derivative is 0, or where the first derivative is equal to 0, which means I have two critical points, a max and min, two minimums, two maximums. I have to have something like that. So I'm ending up with one max and one min. So this one right here says x is going to be equal to 2/3, and this is x equals negative 2. Those indicate where I have maxes and mins. Okay, so now I'm going to take my number line and I'm going to say, oh, well, negative 2 and positive 2/3, and I'm going to test my first derivative to see what happens. I'm going to grab a different color ink here so you can see a little bit better. So I'm going to pick values that are smaller than negative 2 to see what happens on the left side of negative 2. And I'm going to try negative 3. Over here I'm going to test a 0 because that falls in between. And over here I'm going to test a positive 1. I like to keep the numbers simple. So if I do f prime of negative 3, I go back to my first derivative, and this is where I substitute the value in. Do not go back to your original function. It's called the first derivative test. So when I substitute in a negative 3, I would get 12 parentheses negative 3 squared plus 16 times negative 3 minus 16. And you end up with a positive value. Okay, that tells me that the function is increasing over that interval. So from negative infinity all the way to 2, this is increasing. What happens when I test 0? So if I put in a 0, I get a negative because it'll wipe out the 12x squared, it'll wipe out the 16x and leave me with a negative 16. If I use it over here and I substitute in a 1, I have f prime of 1, again into the first derivative, is 12 times 1 squared plus 16 times 1 minus 16, and I end up with a positive. So that means that my intervals of increase, okay, so f of x, the original function, increases between negative infinity and negative 2, union with 2/3 to positive infinity. But f of x decreases from negative 2 to 2/3. Okay, so this is where my slopes are negative, which means it's decreasing, and then over here, this is where my slopes are positive, which means it's increasing. Okay, so I'm leaving numbers 5 and 6 for you to try on your own, but I'm going to leave you with a couple extra steps here. Not extra steps, but just the steps to make sure you follow it. The first thing you need to do is find your max and mins. Okay, and you're going to do that by taking the first derivative and setting it equal to 0 and finding those values. You want to substitute those values into the original function to find the ordered pairs. So that's an extra step that's listed on the directions on the back. The second thing you're going to do is use the first derivative test. This is that number line test where you're looking on the left and then the right and sometimes in between those values. And this is going to determine your intervals of increase and decrease. Okay, please leave any notes or any questions that you have for me on Schoology, and we'll talk about this the next time we're together.